Hello everyone, today I want to talk about some very basic but very important Ohm's law. So what Ohm's law is about is basically like the relationship between voltage, current and resistance. So basically the equation is voltage equals current times resistance, and voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. So what you should know that, let's say the resistance is the same, and you increase the voltage, the current will also increase. That's if the resistance is the same. So like resistance it's constant, right? It's the same. So increasing voltage increases current, and the same in opposite way. And let's say the voltage is the same and you increase the resistance, the current will decrease, because basically the current is how much electrons can throw, and resistance stopping it. So the more stop, the less flow. So here's an example. Let's say we have a circuit, the voltage is 12 and the resistance is 4, and we need to find out the current. So V equals IR. We just need to do the rearranging. So we put this here, I equals, and when you do this, we just put the so basically voltage divided by resistance. That's how it is in the, when you I is the what's called the subject. So the volt, so it's 12, the resistance is 4, and the answer is 3. So the answer would be 3 amps because that's the current, so 3. So here's another example. This time we have 3 resistors in our series circuit. I'm pretty sure this is series. And how we solve this is basically the resistance, total resistance equals basically R1 plus R2 plus R3. So all these added up, which basically just goes to 12 ohms. And as we know, voltage equals IR. Again, that means I mean V over R. So we do the 60 divided by 12, which gives us 5. So the current is 5 amps. So now that we got the current, we're able to find out what is the voltage drop in each resistor. So it's basically the same law, it's this equation, but we just can't just put the numbers in. So because this is in series, series, the current is the same because it's in a straight line. There's no this, it would be different, but we're going to talk about that in the different video. Basically what we do is V equals I times R, which literally right here. So for example, for the first one, it would be 5 because the current is 5, and it's the same everywhere because they're in a series. And that would be let's do it like this. Basically 5 times 3 equals 15. So the voltage drop here would be 15. 5 times 4 is 20. 5 times 5 is 25, and 25 plus 20 plus 15 equals 60. And as you can see, that does make sense because so the voltage is 60 and the sum of the voltages is also 60. It can't be otherwise because that's the Kirchhoff's voltage law, and that's just kind of basic knowledge sense. So let's say if it's a closed circuit, which is it goes in, the voltage, it goes right, it doesn't have it has somewhere to go back, it would just blow up. That isn't that. It's kind of logical. You can't have a bottle of 20 liters and then expect it to let's say you pour it in a 20-liter box, right? You can't expect it to get more or less. How much voltage is given, that's how much it will get back to the negative point, and it's not going to add up, it'll cancel each other out, so it won't blow up, everything's safe. So that's how you do this type of stuff. So now we have the parallel circuit, and now let's try to do it with this question. Basically, so there is an equation that's like RT equals 1 over. However, we can do it in a more simple way. So we have the resistors, like the values of them. And remember, even though they're in parallel, the voltage across all of these are still the same. So we're able to just, like, remember, VI equals IR. We have the V, we have the R. Yes, it's not all together, they're separate. However, they all still add up to 12 volts. Like this, it's again about you give, you take. It's all around the circuit. It's equal, it's balanced. That's the word, balance. So it doesn't blow up. So what we're able to do is I equals V R. I said this like like many times, but you have to know this yourself. It's rearranging formulas, basic knowledge, guys. 12 over 3. Let's do the first one, and that will go to 4. So in R1, the current is 4 amps. In R2, 12 divided by 4 is 3. So in this one's 3 amps. In this one, 12 divided by 6 equals 2. So 2 amps. And this is how you can see where, so over here the resistance goes up, so the current goes down. So this one has the biggest current, or the biggest resistance, and it has the lowest current. This one has the lowest resistance and has the biggest current out of all these three. So you just have to, I mean, that's also kind of logical. So after that, we're able to say, okay, well, we have the currents for like, you know, the separate ones, but what is the total current? Let's just call it total current. Well, it's also very logical. Again, Kirchhoff's current law is the same as the voltage, where like you give, you take. These all add up to the total of the current, because the current is the electric flow, so there can't be more or less. These added all together gives us 9. However, after that, now, in the parallel circuits, there are the junctions, I'm pretty sure they're called, where, so you know how over here there's 4, and over here there's 3, and over here there's 2? That means that, how can I explain? So let's just use purple for this so you can actually see. So let's say the current is going, yeah, at the start it's 9 amps. It's going, oops, a junction. The current pulls, like, basically this junction takes the current that it needs, or I'm not really sure how that works, but it just takes the 4. So take away 4, it leaves, it now has 5 left. Goes, okay, takes another 3. So now there's 3 left. No, now there is, I'm lying, there's 2 left. Sorry for that. So it goes there, over here, after that. There's nothing after this point, there's nothing taken to it. So it's left with 2 amps, and the 2 amps go like this. So 2 amps over here, go over here. Now, you know how the electric go like this, yeah? Because it's like, it connects back at the end, like again, total here brings the total back because it's balanced. So while this one goes out, this one goes here, and it takes the 3 back, which 2 plus 3 equals 5 amps. And then over here it goes and it connects, and 9 amps. And that's how like current works. So that's kind of the point. And if we want, we can calculate the voltage of each like resistor, but basically in general, again, you should already know how to do it. No, let's do a different color, let's do green. So voltage equals IR. So we have the I, we have the R, so you can just do, oh, and here, and as you see, like right now you're going to be quite, not shocked, but like impressed, I guess, because 4 times 3 equals 12, which is already the maximum, like the maximum in brackets. I'm showing mine rabbit ears on my hands. So you have to kind of think of it. Yes, it's like balanced out. However, it's balanced out in the way that each circuit, you don't think of it as a, how I think of it is, for me, this is all, it's not like a full circuit. These circuits, they're basically split because, like, yeah, they are split. So I kind of think of it of a different one. The reason for that is, look, this one equals 2 for 12, R1. Same with R2. 3 times 4 equals 12. 2 times 6 equals 12. So the voltage, like in parallel, the voltages, it is equal to like the separate resistors. However, that's if you have a parallel resistor circuit, or it gets very complex. However, you just have to know that now. And that's it for today. Thanks.